Today I'm going to be forging the large saw that was part of the Mastermyr chest, which was a big archaeological find in the mid-1980s. Hi, I'm Dennis Frechette and welcome back. Today I'm going to be working on the large saw that was part of the toolbox that was found in Norway. It was believed that some craftsperson was crossing the ice at some point and broke through, maybe saved himself. We have no way of knowing that, but definitely the toolbox went to the bottom and stayed there for a long time. There's a lot of videos on YouTube that are dealing with all the other tools, all the popular tools like the axes and the adzes and that sort of thing, but no one's ever actually done a saw that I'm aware of. So I've always wondered how a hand-forged saw would work, so that's what I have for you today. I'm going to make one, try it out, and see how it works. So hope you find it interesting. The information that I used to make this saw was found in the Mastermyr Find, printed by Skipjack Press, and it is still in print, so it is, I believe, the only readily available public copy of the record of this find. The book does contain photographs of most of the artifacts that are in the chest, but they do have archaeological drawings of every artifact that was in that chest, including the chest itself. So there's a brief description, there's the archaeological drawings, and more importantly, there are measurements of everything that was in that chest. And when it comes to the saws, there are the critical ones that you want to know that you can't tell by looking at a drawing, and that is, how thick was that blade? Unfortunately, the fine teeth of the saw suffered the most corrosion, so there was no definitive description of how the teeth were made. For example, there was a smaller saw blade in this toolbox, and it seems to have alternating teeth that looked like they had a fairly fine point to them, much the way a bucksaw blade would be shaped today. But was that from corrosion, or was that the original shape of the blade? There's no way of knowing. The material that I'm going to be using is this section of leaf spring. It was much wider, of course. It's been cut down quite a bit. So this is the last piece that I have. It's roughly 1.25 inches wide, and unwrapped, maybe it's a foot long. So by the time I get this forged out, this will make a shorter version of the large saw that was featured in the book. But the important thing isn't the actual length of the blade, but to make sure that I have the same thickness as the original and roughly the same number of teeth. That's what's going to determine how well this saw works. The book didn't go into a lot of detail about the saw teeth on this saw, mainly because they were probably just a series of lumps, but they could identify these lumps as teeth, and they did say that they were offset in groups of 4 or 5. So this creates kind of a wavy edge, much the way you would see on a modern hacksaw blade. So that suggests to me that the teeth are probably the full width of the blade. So that's what I'm going with. I'm going to leave the teeth the full width of the blade, the full 1/8 of an inch, and I'm going to create a wavy pattern in the blade edge to create the curve, because the teeth are going to be too thick to actually put modern set the way we do today. We push the teeth over in either direction to create a curve. Here, it appears as though they just forged the whole blade in an S-curve to create the curve and left the teeth alone. You have to also consider that at this time, saws were not a major player in any woodworking operation. You know, pieces were roughed out by splitting, and then they were further refined with single-edge tools that were much simpler to sharpen, like axes and chisels and draw knives. So these saws may have been viewed as a non-essential, and who knows, maybe even a luxury item, because they did make certain jobs a lot easier. But if you didn't have one, it wasn't really a big handicap. And that's one of the questions that I was hoping to answer by doing this experiment. Would this saw have done any reasonable amount of cutting that would have made it worth all the time and effort that it would have taken to hand forge a saw blade at that time? At this point, I'm just finishing up the shaping of the tang. I've moved the tang up in the blade. The original had it very close to the bottom edge of the blade, in line with the teeth. I've moved it to the top edge of the blade. It's not going to affect the functioning of the blade at all. I just think it looks a lot better. The next thing that I need to do is to start drawing out the blade. I don't need any more length, so I'm going to take my cross peen and hammer across the width of the blade to give me the final dimensions that I need to match the original. All I'm trying to do here is to distribute the mass where it needs to be. So I'm basically, as always, working in stages. I'll do part of the process, move on to the next section, bring that to the same level, and work my way down the blade, and then I'll start from the other end and work my way back, refining the shape as I go until I get the final thickness that I need. At this point, I've completed the first pass on the blade, so I was working from basically the center line and pushing the material towards the cutting edge where the teeth are. In this pass, I'm going to be working from roughly the center again, but I'm going to be moving the material upwards towards the top edge of the saw. And again, working my way back in the opposite direction. This should get the material pretty close to its final thickness. For the third set of passes, I'm basically just using the flat side of my hammer and hammer refining the edge as much as I can. I'm going to be flipping the blade over as much as I can to even out the heat in the blade and to keep the stress as even as I possibly can. But basically, this is all hammer refining and working to the final thickness and trying to get the entire blade to be as consistent as I can. I should mention that I have no plans of heat treating this blade. I'm going to leave it as forged. I made it out of a better quality steel, so I'm going to rely on the inherent toughness of that steel to provide a good cutting edge. Heat treating would only extend the amount of time that I would get out of the use of the saw before I needed to resharpen the teeth again. It would not affect the actual cutting edges. So I'm just going to skip that whole step because I'm really not planning on using this saw beyond this video. At this point, I'm quite a bit further along. The blade is pretty much done, or at least all the shaping that I'm going to be doing on this blade right now. Um, I haven't done any grinding or refining. The forged scale that's on the outside is going to stay there. It appears that that was how the original blade was left. There was no evidence of any tool marks or any refining, so that's how I'm leaving it. I did go ahead and rough in the saw teeth. I also used a grinder to straighten out the cutting edge slightly. It's not perfect by any means, but just by sighting by eye, I was able to get rid of, the major inaccuracy. So I feel it's an acceptable level of accuracy for this tool. I was a little disappointed that they didn't list how many teeth per inch there were on this blade, but they did mention that the teeth were offset in groups of 4, and in the photograph you can clearly see the shadow lines from all of these offsets. So I was able to count how many offsets, do a rough estimate for how long the blade was, and then, just kind of calculate how many teeth. And I came up with roughly 6 teeth per inch. So I use a set of dividers to lay out a 6-tooth pattern on a scrap piece of metal. I cut that in, and I was able to clamp that to the blade and scribe around it, and then shift it along the blade to create all of the teeth that I needed along the edge. From there, I used a hacksaw to cut in the vertical face of the tooth, and I used a thin cutoff wheel on my angle grinder to rough in the bevel of each tooth. So this is what the saw blade looks like at this point. It has a very aggressive tooth pattern, and there are flat edges on the tops of all the teeth, so there are no sharp edges anywhere on this blade at this point. Here I'm getting ready to set the teeth by pushing a section of the blade off the center line, and then I'll work my way down the blade, flipping each time to create a wavy pattern that, again, goes off the center line and creates the curve, which is what you need to run a saw blade. The cutting edge has to be wider than the actual thickness of the blade, otherwise it'll jam in the cut. At this point, I'm a little further along. I've completed one pass, so I have the pattern basically set, but I need to refine it. Some areas need to be a little deeper, and I need to take away from some other areas. So that's what I'm working on now. I've also realized that if I flip the blade around, it'll support itself. So I don't need that big, chunky, square pipe that was sitting on the anvil. It was just getting in the way. So this is working a lot better. At this point, I'm going to be doing my first test on the blade. I haven't done anything to the cutting edge. It's just roughed in the way I described earlier, so I just want to see how the teeth perform at this point. And the first thing that struck me is that this thing is doing the exact opposite of what I thought it was going to do. I thought it was going to be fighting me the whole way, to a point where I was going to be struggling to even get it to go through the wood. But as it turns out, I was really applying very little pressure to get this to cut. And, sure, it's not a very long cut, but again, this saw probably wasn't going to be used for anything more than this. So even as it stands right now in this crude state, this is a very useful tool. Here I've jumped up to a 2x4 just to see, what'll happen on a larger piece of wood. And as expected, I am having trouble getting the teeth to start, and I need to apply quite a bit more pressure to get the teeth to cut. After all, there are no real cutting edges on these teeth. But despite all that, it really didn't do too badly at all. The next thing that I did is I used a triangular file to sharpen the teeth. I didn't reprofile all of the teeth. I just used the file to refine the vertical face of, the one tooth as well as the top face of the adjacent tooth. This created a sharp point which gave me a cutting edge on each tooth. Here I have the finished blade. You can see that the shiny spots on the teeth are at the very tips. There's nothing else done to this blade. I still have the forged finish on the edge. I did borrow a file handle to be able to have a handle on this, but basically the actual blade is exactly the same. Here I'm getting ready to do the second cut test. I'm going to be using the same 2x4 that I used in the first test because I want to be able to compare how much easier this cut is going to be compared to the first one. I was able to cut into the first one, but it was hard to get started, so I am expecting quite a big improvement here because I did spend some time sharpening the teeth. And the teeth are cutting very well, which still surprises me because this is creating a wide curve and I'm removing a lot of material here, but I'm not applying a lot of downward pressure to make these cuts, and the saw doesn't seem to want to hang up anywhere. So as crude as this thing is by today's standards, it definitely would have been a very useful tool to have, even if it wasn't something that was used on a daily basis.